Hi folks, a couple of weeks ago the Astro Imaging channel gave us a challenge on processing the data that was captured by Eric Coles, which was kind of chosen in APOD. And what he's got is basically the Cave Nebula in the all the channels that we're using. We have the RGB channels and the HA, sulfur, and O3. This is a combination of the image using the Hubble palette S2 for the red channel, HA for the blue channel or green channel, and then O3 for the red channel. I mean green channel, and that was the what I got. Essentially, I submitted this, and um, it was pretty good. Anyway, let me go now to the RGB channel. So far, what I did is I just made a simple combination. Well, first I did is I aligned all the channels and then did a little RGB combination with the linear images, and this is what I got. It's pretty cool. But the thing is, there's a lot of things that I need to fix first, meaning look at the noise. It's clearly seen, we can clearly see it, but otherwise that is good. Now if I'm going to just join the or just combine all these nonlinear images, as you can see I already made it as a nonlinear, already applied this um, what you call this, I okay, let me go back, this thing which is basically stretching the image. All right, let me just clear that out. um, okay, let me do that. Let's apply this guy and then clear this out. Okay, so that is now the nonlinear images, but what you can see here is the image is still very noisy. So what we should do next is try to denoise it at the before we even combine it. So I have a value here for TGV denoise, and let's see what's going to be the impact. So usually I already have the values, but let's create a preview first on how it's going to look like if we apply on that particular space. mm, I think that's okay. Reset. Yep, I think that's okay. So we can delete this now and then apply it to the real image. I'm going to pause every time I'm going to apply this TGV denoise through all the RGB channels because it takes a lot of time. All right, essentially, oh, sorry, just put it there. It's going to count. Okay, pause. All right, I'm back. So all of those are now denoised images. Now let's see how we can compare it with the original. So all you have to do is do this. Ah, sorry, crappy. Okay, so let's remove that. I made it as a mask. Anyway, so the way to see the difference is clone. Oh, I cannot clone. There you go. And then you can put this back to the original. So you see that none of the probably there. We've lost a little bit. I think the noising is a little bit aggressive, so we don't have to do anything here. Now let's combine and see the difference. that is pretty. Let me just close this thing because we don't need it. Okay, let's compare it with this one. So there's definitely a difference of the color, probably the saturation. You see here the image is, well, it's okay. Yep, so those two things. So none of the structure has been affected, but we can clearly see that this image is actually better. All right, so there's a utility here that I do. Color calibration. Let's hope we can find this. Cave Nebula. There you go. Got it? Okay, so while that is doing that, I'm just going to pause again. So unfortunately, PixInsight cannot solve it. The plate solving is not working. Alright, anyway, we can do this ourselves. So probably one thing that we need to do is put a little bit of a contrast, or remove a little bit of those tiny stars. Let's work on the stars first. So on the stars, we can do mask, star mask. Let's just use this default value, and then okay, it's taking a long time. Probably time to upgrade my computer. Okay, so there's a lot of stars in the background, so let's just apply it there. All right, so we can see the stars. There are a lot of ways where we can remove the stars. Normally what I do is first go to the curves just to remove it. Where is the curves? Okay, so making sure that the mask is covering, the red part is protecting that part, and the stars are basically the one that we're going to edit here. So just hide it, but we know that the mask is there. Okay, and then the saturation, nothing, and then the lightness, too much. So here you need to be very careful. So that makes all the stars very bright. Yeah, too much. Okay, probably that one. So you see the amount of change that I'm doing. It's very, very small. Okay. That's okay. There's some visible changes now. More. Alright, that's probably better. Okay. So remove this. There's a clear visible change. There's a little bit of ringing. Actually, yeah. Alright, probably that's not a good idea. Let's do morphological transform, and again to see. Okay, we're protected there. There you go. I see some change. And no, the ringing. All right, probably good. Okay. So again, the mask is still there. Now let's invert the mask and apply the transform on the image and not the stars. Clear this out. Apply a little bit more saturation. There you go. I can see more red. Okay. And then light. There you go. You see a little bit of a change in the background. Right. There you go. And then no, too much. Just make this a little bit of an S curve. Nice. I can see the red. Let's see. Okay, I see a lot of the ringing there. This one's a little bit of an S curve also. S curve. Too much on the stars. Okay, let's clear this out. Let's play with this guy. Better. I can see a lot of the contrast there now. Just to be very careful here, make sure that you're not hurting the image. That's good. I can see a little bit of those things now. The nebulosity. I think that's enough for me. Good enough. Okay. And then remove the mask. Alright, and let's attack a little bit of those tiny problems that we have here. So we can apply the Rgb denoise again. Let's get something here. The preview. Okay, that's good. Now this will take a long time. I'll just pause and resume after the Rgb denoise is done. Alright, so that's done. So that's the change. It didn't really hurt the nebulosity. Let me go back. There you go. But clearly we fixed a lot of those noises. Alright, so noise reduction is awesome. Wow, this image is really nice. Turning to be really nice. Anyway, let me just do a little bit of the background modernization. Let's just do automatic. Alright, target correction, subtraction, normalize, replace target. I'm just going to keep the default values. Okay, so that's what we've removed. Let's see what was the impact. Oh, there you go. Yep, definitely better. And then what else? There's still some. I can't think of anything else now because I'm really satisfied with the result of the image. Alright, so Next thing is to make the image counterclockwise. Ah, bad. 80. All right, there you go. Let's close this out now. Yes, it's really that simple. I really hate complex processing. So for me, I stick to the basic. I stick to the very simple processing, and there you go. That's what I got. A lot better. This is the result of the narrowband channels, and this is the result of the RGB. Okay, I'm not going to do any cropping here. I don't usually do crop, so just to give the entire image. Probably we'll do a little bit of um, uh, what kind of thing that we can get. Let's do histogram a little bit. Okay, show a little bit of, no, probably, there you go, just a little bit of that. And then the star should be, let's go with white, just a little bit of red. No, I think that's better. Increase a little bit of that red to show that those nebulosity, so you can really see how the impact is. A little bit of a change can make a big impact on the image. And green should be less. Alright, and then blue as is. Alright, hello. So just continuing on what I have on this cave nebula. So I did a little bit of unsharp mask, and there's definitely a big change. I did a little bit of different processing, but now I'm going to save this. Save us as a TIFF file, and then we can say 16-bit. Alright, that's being saved, and then we can now go to, actually I already have it in, but to show you guys, let's open it again. Cave Nebula, there you go. And here, just a little bit of small changes. We can add levels here. Don't change anything there, or don't pull that, because we're going to lose data. We can make it brighter a little bit or darker. So that's it. You can see the changes, and then let's do a little bit of curves. So for these curves, I want to see a little bit of this nebulosity. So probably turn this down a little bit. There you go. Or turn it up a little bit. It doesn't matter. But for the curves, it's actually the S shape that will really help us. So this, there you go. I see a little bit of change in there. And then you see the stars lighting up, and then the velocity. Probably let's do it here. And let's trim down a little bit because of the stars. There you go. So definitely better. We can see the changes. So you can see that this nebulosity became brighter. So usually that's what I do. And if we're going to take a little bit closer, do we really need to add a lot of denoising cell? Let's go back to that filter, the speckle. All right, probably one more, probably the speckle again. All right, that's better. I don't want to touch the stars anymore, but if we want to make it smaller, because there's a lot of stars in there, can do a little bit of this minimum. So from here, you don't need to be really aggressive. So you see the brightness of the star. Okay, let's see. There you go. That's the effect of the minimum. I can see the effect of the minimum. Let's undo. Let's see. All right. I'm happy with this image anyway. So normally what I do is I just add my text, my name, my signature here, and that's it. All right, folks. Thanks for watching again. Bye bye.